Imagine a computer changing part of the system used to build its successor. It tests the revision and keeps the version that appears better. Then it starts again. This is different from an ordinary tool. It is not only producing an answer, it is improving the process that produces future machines. A smarter machine is not the singularity. Neither is AGI. In its AI-centered form, the singularity is the proposed threshold where intelligence accelerates the creation of more intelligence. Beyond it, humanity may no longer reliably predict or direct what the next cycle produces. Artificial intelligence covers machines performing cognitive tasks. Artificial general intelligence, or AGI, often means broad ability across many tasks. Superintelligence refers to intellectual capability far beyond the strongest human minds across most important domains. Recursive self-improvement means a system repeatedly improving its own ability to create still more capable versions of itself. An intelligence explosion is the compounding that might follow if each improvement makes the next one easier. The technological singularity is the larger historical boundary such acceleration might create. These ideas are related, but none guarantees the next, and AGI could exist without producing a singularity. It requires neither consciousness, a humanoid body, infinite intelligence, nor one dramatic midnight. It describes a limit of prediction, where the forces creating the future change faster than familiar models can follow. The idea predates conversational AI. In 1958, mathematician Stanisław Ulam recalled John von Neumann discussing accelerating technology and a break in human history. It was an intuition, not yet an explanation of how machines might improve machines. 7 years later, British mathematician I.J. Good supplied the mechanism that became central to the AI version of the idea. He imagined a machine surpassing humans at intellectual work, including machine design. If it designed a better successor, that successor might improve the process again. Good called the possible result an intelligence explosion. The question was no longer only what a machine could do, but what it could help create next. In 1993, mathematician and writer Vernor Vinge gave the idea its influential modern frame. Greater than human intelligence, he argued, could produce change too profound for familiar models of history to follow. The singularity became a horizon. We might recognize the signs that we are approaching it without being able to map what lies beyond. Vinge considered intelligent computers, connected networks, human-computer partnerships, and biological enhancement as possible routes. Ray Kurzweil later popularized an optimistic vision based on accelerating computation and potential human-machine integration. His forecast became famous, but it remains one interpretation rather than the definition of the concept. Across the AI-centered versions that followed, the common spine is intelligence becoming an improvable technology. A real improvement cycle needs more than changed code. The process must propose or discover a useful revision, implement it, and test it against meaningful goals. The change might affect an algorithm, training method, model design, data pipeline, chip layout, or research workflow. Imagine the new version completes one benchmark faster but fails more often on unfamiliar tasks. Did it improve or merely learn to look better under one test? That decision is the evaluation bottleneck. A machine can generate thousands of modifications and still lack a dependable way to determine which should survive. Weak tests can reward shortcuts, conceal failures, and push later cycles in the wrong direction. open-ended recursive improvement would likely require broad reasoning, reproducible experiments, sound evaluation, and access to the infrastructure that turns proposals into working systems. For an intelligence explosion, enough of the loop would have to close without reliability collapsing. Pieces already exist. AI assists programmers, compares candidate designs, and explores bounded research problems. Specialized tools have discovered faster algorithms for sorting digital information, improved other important routines, and generated chip layouts used in real engineering workflows. Experimental AI scientist projects can propose ideas, write code, run limited experiments, and draft papers in prepared environments. These systems can automate portions of research, but none has demonstrated reliable, open-ended control of the whole improvement process. Humans still set the surrounding objectives and constraints, provide computing infrastructure, repair failures, shape evaluations, and approve real deployment. Even brilliant software cannot manufacture a processor by thinking harder at a server rack. A chip still requires a completed design, photo masks, silicon wafers, cleanroom fabrication, repeated lithography, packaging, and testing. Data centers depend on land, electricity, transformers, cooling systems, hardware, financing, and maintenance. Medicines, materials, and energy systems remain tied to some combination of laboratory trials, approvals, factories, and construction. An automated researcher might shorten discovery, but it cannot make fabrication equipment or physics disappear. Intelligence may accelerate design while the physical world keeps its own calendar. Software speed is not civilizational speed. The loop can also slow inside the machine. Each advance could demand more processing power, cleaner data, or greater engineering effort than the last. In many observed scaling relationships, additional compute improves measured performance, but returns diminish as resources increase. As original material becomes harder to find, models may begin learning from copies of copies. Like a photocopy reproduced too many times, errors accumulate while fine details fade away. A model reviewing its own work can carry the same blind spots into the assessment. Errors can compound through repeated cycles instead of disappearing. Some problems yield to faster search. Others may require a new theory, an unexpected experiment, or evidence that does not yet exist. A system might excel at coding while remaining fragile at planning, decision-making, long projects, or recovery from failure. Intelligence is not one dial. Improving one capability does not move every other capability with it. Three broad possibilities remain. In a hard takeoff, capability rises so quickly that human institutions cannot understand or respond in time. In a soft transition, change arrives through better assistance, faster laboratories, improved chips, and ordinary-looking systems that gradually automate more human steps. There may be no single morning called the Singularity. People may notice only afterward that invention no longer works as it once did. The third path is that recursive improvement meets lasting technical, physical, economic, or conceptual limits. The loop slows, remains dependent on people, or never closes at all. Informed observers disagree because they make different assumptions about improvement rates, evaluation quality, scaling returns, and deployment speed. No publicly documented system has yet demonstrated reliable, open-ended recursive improvement of its own general capabilities. Prediction asks when the boundary will arrive. Preparation asks which decisions should remain visible, testable, reversible, and accountable. A system needs neither consciousness nor a human-like body to change the authorship of technology. That shift could begin with growing influence over which problems are chosen, which designs are tested, and which successes are released. Humanity has always built tools that extend memory, strength, communication, and thought. The Singularity raises the possibility that one of them may eventually help determine what intelligence becomes next. Uncertainty does not erase responsibility. It makes accountability necessary before prediction becomes certainty. Whichever path proves true, the choices made before it remain ours. From machines that extend the mind to a horizon that the mind may no longer map, you are always welcome here. At Illumentary,